Welcome to tuitionprep.com, and today I'm going to go through 3 worded problems that are quite complex, and I'm going to use my favourite thing in the whole wide world, bar models. So let's move on to the first question, and here it is. So I'm thinking of a number. 2/5 of my number is 12. What is half of my number? So those are the key facts that we need to consider. And I'm going to represent all of that information as a bar model. So my first starting point is to represent the mystery number that I'm thinking of as a bar model. And there it is. There is my mystery number. Now you notice I've divided it up into 5 equal sections. Well, that's because the question stated that 2/5 of the number was 12. So I've represented 2 out of the 5 bars in red, and I've said that number is 12. But that doesn't mean that each bar is 12. It means the total of those 2 bars are 12. So what I'm going to do is to split that 12 across the 2 red bars, like so and like so. So it's 6 in each. Now the rule with bar models, which is the best thing in the world, is that whatever goes into one bar, as long as the bars are equal in size and value, that number can go into the other bars as well. So I can very happily put 6 and very confidently put 6 into the other bars, like so. And now I can look at that and I can say to myself, well, 6 and 6 and 6 and 6 and 6 is 5 lots of 6s is 30. So I can say confidently that the number I was thinking of is 30. But remember, the question was asking what was half of my number. So I'm now going to redraw the bar model with slightly tidied up, slightly tidied up version. Here we go. So there we are. We're back to our 30 again, but this time I've split it into half because the question was saying what is half of the number I was thinking of, and half of 30 is 15. So 15 would be the answer to the first question. The second question, slightly more complex. 5/8 of the books on a shelf are fiction, and the remaining books are non-fiction, and there are 72 books which are non-fiction. So we can say that we have a fact about fiction books and we have a fact about the non-fiction books. One's a numerical value, the other is a fraction. And the question is asking us how many books are fiction. So how are we going to represent all of that information and the question on a bar model? Well, straight away I see that the fraction is 5/8. I notice that the denominator has an 8, so my bar model should be represented with 8 equal bars. And it should look a little bit like that. So as you can see here, I've got a long bar which represents all the books on the bookshelf, and I've got 5 bars in red, which is the 5/8, which are the fiction, and we have 3 bars in green, which are the non-fiction. Now I've got a value of 72 non-fiction books, but I need to distribute that 72 across the bars. Now be careful here. 72 doesn't go into each bar. It's distributed across the 3 of them. So how am I going to split the 72 books across the 3 bars? Well, I think the best thing to do here would be to do some bus stop method. So let's do it here. Slightly slanted, but it doesn't matter. So 72 divided by 3, because there are 3 bars. So 7 divided by 3 will give us 2 with a remainder of 1. I'll put the 1 there. Remember that 1 actually is 10. It's 10 units or 10 ones regrouped into the ones column to give us 12 ones. So 12 divided by 3 is 4. So we get 24. So what that means is we should be putting 24 into each of those green bars, not 72 into each. Now, the best thing about bar models is that whatever you put into one bar, as long as the other bars are the same size, the same number can go into them. So we can put a 24 into each of the remaining red bars. And that's one of the beautiful things about bar models. Now our bar model is populated, it's completely filled up with all the key information. Now we can see if we can address the question. The question was saying, how many books are fiction? Well, I can see immediately because I've labeled my bar model really clearly with all the correct information, and I can see that I've got this section here in red is the fiction, and I've got 24, and I've got the 24 5 times. So I'm going to do a quick column multiplication. 24 times 5. 5 times 4 is 20. Put my 2 down there. 5 times 2 is 10, plus 2 is 12, so I get 120. So I can say there are 120 books, and it should pop up there. So it's 120 books are fiction. Let's move on to the final question, which I believe is the most challenging. So we have 2 children. We have Rosie and we have John. Rosie has 207 sweets. John has 150 sweets. I'm sure in your mind you can almost start to imagine what the bar model is going to look like and who's going to have the slightly longer bar. Well, Rosie's going to have the longer bar and John's bar is going to be slightly shorter. We'll see that on the next slide. Now, John decides very generously to give some of his sweets to Rosie. So what that means is Rosie is now going to increase the number of sweets she has and John's number of sweets is going to go down. His bar is going to get smaller, whereas Rosie's is going to get slightly larger. But what happens is that when the bar model is changed to increase Rosie's and reduce John's, what that means now is that Rosie is now going to have double the amount of sweets as John. So how many sweets did John give Rosie? Well, let's have a look at all of that key information on the slides. So firstly, let's start with Rosie. Rosie had 207 sweets. John had 150. So you can see John's bar is slightly smaller than Rosie's. And John gives some sweets to Rosie. How are we going to represent that? And how much of the bar should we chop off? So should we be thinking about chopping off a part of the red bar and placing it here? Well, that would be strictly what we should do. But how much do we cut off? We don't know. Do we take a little piece there and pop it there and see if it works out to be double? Well, no, that's just not going to help us really. Now, what does it actually mean when someone has double the amount of sweets as someone else? Well, I think it's going to look like that. Now, the colours represent, the green colour represents Rosie and red still represents John. All I've done now is I've represented Rosie as having double the amount of John. That's all I've done. I'm not going to even worry too much about what the bars look like, but one thing I can say is the bars are all the same size because they have to be. These two is double this. So that's my starting point. But here's another question to think about. How many sweets do they have altogether? Even if they weren't changing sweets or swapping with each other or any of that stuff, what's the total number of sweets they both have? Well, I would say it's going to be 207 plus 150, which in this case is 357. So I can say very confidently that the number of sweets they both have is 357. Have you got any ideas what I'm going to do next? Well, hopefully you've figured out that we have a total that we now need to distribute across the bar model. So I'm going to do the bus stop method. 357 divided by 3. In fact, I've got it down here. So 3 divided by 3 is 1. 5 divided by 3 is 1 with a remainder of 2. We now have 27 because that 2 is actually 2 tens. 27 divided by 3 is 9. So I can put 119 into each of the bar models. 119 plus 119 plus 119 is still the same amount of sweets as we had at the start of the question here, which is 357. If that's a bit confusing, I strongly suggest stop the video and have a little think about that. Now, what was the next part of the question? The question was saying, how many sweets did John give to Rosie? Well, we can see this is where he started. He started with 150 and he's ended up with 119. So the last step would be to simply do a column subtraction, and you can see the answer's already there, but let's just confirm it is correct. So it's 150 subtract 119. 0 take away 9 we cannot do. We're going to exchange 110 from the tens column. We're going to regroup it into the ones column. So that 1 is actually a 10, 10 ones or 10 units. 10 minus 9 is 1. 4 Tens minus 110 is 3 tens. And 100 minus 100 is no hundreds. So the answer, as was correctly stated there, is 31 sweets. So John gave Rosie 31 sweets. I hope you enjoyed today's video. Please subscribe to the channel or go to tuitionprep.com for more information.